create a table for me. So GIS results, I'm going to call it max L to B.
Do we need to worry about projections in this right now?
Should you?
Yeah.
You should. Yes. Did you guys hear what he asked me? The answer to this question is you always should worry about projection. And you always should worry about vertical data. That's why in my 3-minute GIS introduction, I talked about datums, projections, and formats, because that's the thing that should be always, when you're working at DuBerry, you should always be thinking about what projection, what vertical data, I've heard so many times of studies that use the wrong freaking vertical data in the water levels and things like that, and it's just like, look. The same thing with units. Feet, meters, what are you using, kind of things. I'm cruising through it because I wanted to show you guys the functionality. And then when you're doing it by yourself, you should always be thinking about those things. What we did is we hard-coded lat long on our import nodes tool. That's what we did it. Therefore, I started with a blank map that had no projection. So GIS starts blank, and it assumes the projection of the first layer that you add. So the first thing that you add here assumes that projection for your data frame. The first thing we added was our nodes, and that had a lat long projection, and therefore everything gets reprojected in lat long. Okay, so I did get a table, and let's look at this table. What that is my Fort 63 MaxL table in a GIS format, and the node ID is the node ID from my mesh, and this is the max water level from that file. So the table per se, it's not really useful, but what we wanted to do, where's my nodes here? So we wanted to join that table with my node shapefile, because remember, we solved the shallow water equations per node. So this represents a node. So if we join them, so if you don't remember how to join, right click, join and relates, join. Join attributes from a table, that would be based on my node ID. Very important. Make a note for yourself. We're joining a shapefile, a point file with a table. It's asking me, how do I relate these things? The key here is the node ID, because we solve the shallow water equations at each node, and that's what the table has, node ID, and the mesh has node ID. So you want to match them. So that's what it's asking me here. So node ID to my max L, okay, with my node. And then I can say, okay, sure. It's going to do its thing. Now, if I look at my node layer, before it stopped here, Bathymetry was the last thing that the Fort 14 gave it to me. Now I joined with my MaxL table, so I have the complete picture. So this is a join, it's not permanent though. But we can see things. The next thing we want to do is we want to now see our results at a given place. We're running this huge mesh as a regional model, but really, we want to look at Hampton Roads. So Sharon's project. So I went to the USGS website, and I did download a DEM. So here it is. And I'm using a 1 arcsecond just to show you guys. We can do much better than that. And it's telling me, look, I'm using a different projection.
What did you get to give me?
What?
DEM.
Okay, DEM. Oh, the national map is where you want to go. Here's where you get DEMs for the nation. And I think I showed this before. So you go here and you download your DMs. It's the USGS geoportal. Okay. And then you get a zip file with a DM. You look confused, Kelsey, yes?
I just missed how you inserted it.
Oh, here.
Yeah.
Add,
Oh.
right?
Yeah.
And then you navigate to it.
Okay.
And here it was. That's the one. I'm not going to add it again. You just add it.
Okay.
Okay. So for you guys that need a refresher, add is where you add things. The little triangle here is where it opens the online data. Otherwise, you're just adding. Customize extensions. It's where you add your spatial analyst. You get a lot of questions for that. Okay. So my DM is here somewhere. I can't see it because my mesh is on top of it. So I'm going to right click, zoom to layer. Here it is. So here's my DM. So let's get rid of that. So here's my DM. That's the 1 arcsecond DM from the USGS. Here's my storm path. So here's my topography data. And here are my nodes. So what I'm going to do here to simplify my analysis is I'm going to right click on my node. I'm going to export this data. Export data. So right click, data, export data. Please write that down so you don't get lost when you're doing that by yourself. And then instead of exporting everything, I'm just going to export all features in my view extent. I don't want my entire mesh anymore now because I wanted to do a localized analysis. If you have a fast, good computer, you might not worry about these things. Just trying to make this happen here. I'm going to call this node result. And this will be a shapefile because I want to enjoy it. So what I've done now, I created a new shapefile that's only up to where my DM is, and it also now incorporated the table that was joined to it inside the shapefile. So before it was a join. If you closed ArcMap, that join would have gone away. Now I have a new file that has this, results. So if I right click here and open attribute table, my results are here. And node and node ID should match. If not, something went wrong. You're putting results that are not from this place. Okay. So here we are. Next thing we want to do is we wanted to create a water surface elevation raster. Because if you zoom in, you see that the points are further apart. So we do have result per point, we don't have results everywhere. So to do that, we're going to use interpolation. Where are you? Here it is. There's a bunch of methods. I'm going to go with spline. And I'm going to interpolate my node result. I highly encourage you guys to check those out. The reading for this week talks about producing storm surge maps using interpolation techniques, barriers, and things like that. That is still, on my mind, an open-ended research question here, is how do we do this better, correctly? And I think the way to go here is with geostatistics, so kriging, or you can open up an entire geostatistic toolbox here and do your covariance analysis and things like that. It was hard to do it in the past because we did not have too much data. With the new storms and with the USGS mobile monitoring network, especially for Sandy, we have like maybe 1,000 points of high water marks and water levels and things like that, which is giving us the spatial advantage now. So there's room to explore here. It's how to go from points to everywhere. And remember, our points might not be correct. That's your model simulation. There's got to be an error in there. So there's that. So how do you adjust the model simulation that it gives you the spatial advantage because you have points everywhere? How do you combine that with the measurements for a given storm? So let's say I have a station here and a station there. So those we assume it to be true, but who do we trust in more? The model or the measurements, how much error the measurement has, how much error the model has, and how do we spatially combine them? That's the thing, and the paper talks about these things a little bit. Anyway, my z-value, what's my z-value?
Elevation?
No, result. Right? I want to interpolate my model result. So z, I mean, you think of z as elevation, but in this case, we wanted to interpolate the model result. And I need to save this somewhere, so everything is going here. So let's call it water surface. Supply. And I'm going to change something here that's very key for things to run smooth. Environments. You want to write that down too. Environments. I'm going to adjust my processing extent to the same as my DEM. And I'm going to snap my raster to my DEM. And I think that suffices, but if you want to go here and cell size, same as your DEM. What I'm doing here is I'm forcing my interpolation to create something that will perfectly match the DEM cell. Not the result, but the spatial domain of the cell. Does that make sense? So are you guys familiar with snapping and things like that? Raster? Yes? Okay.
So the two things in advanced were processing extent and raster analysis cell size, right?
Yes. And in processing extent, what did I change? The extent, which just makes it the same spatial domain, and I told you to snap. What snap is doing for you is, if this is your DEM raster, and we have our points, we created a new raster. Snapping makes the new raster be at the exact same location as the other raster. Therefore, they're completely matched. That's what we did. Okay? Because I'm using spline, you can change your spline type, you can change your numbers. That's easy. What's the best one? The paper talks about that. You guys can play with it. See what has an impact or not, what kind of interpolation method you want to use. So let's see if it works. So it's working on my spline. And if it works, I should get a raster that matches my DEM, but it has the model resulted water levels. Is that my flood depth?
Ask it again.
Is that my model results, my flood depth? Is that the same thing?
Is it your max elevation?
That's my max elevation above my datum of the mesh, which was 0, nav D88. Okay? So to get the depth, we need to go from a water elevation to a bathymetry or an elevation. Is that clear? So if you think about it, if this is your profile, and we have those feeders throughout the class, this is mean sea level, or nav D88, whatever is your 0, your model result. Maybe it was something like that. So your model result at this point, let's say is 1.5. But you know, the topography here is 0.5. So your water depth, it's 1 meter. Okay?